Hello, I'm Sayali Lunkad and I work for SUSE, and these are my co-speakers, Johannes Grassler from SUSE as well and Ade Lee from Red Hat. Today we'll be talking about secret management with OpenStack Barbican. So what exactly we're going to talk about is what is Barbican, the packages that are there, the secrets to our backends, then what are the different services in Barbican about, and the use cases for Barbican. So let me tell you what is Barbican. Basically, Barbican is a service that is used for distributing and storing key material and also interaction with certificate authorities. So in OpenStack, there are a lot of SSL keys or secrets or passwords to access the database or the APIs, and also maybe encrypted keys for accessing storage volumes. Barbican allows you to retrieve all these and store all these secrets in a more secure manner. Last but not the least, instances can be used Barbican for accessing certificate authorities supported by the Barbican plugins to submit certificate signing requests. Next, we talk about the packages that are available. So we have RDO packages available and SUSE OpenStack Cloud packages. We also have Ubuntu packages that are already there. We have written Puppet modules and Chef cookbooks for deploying the different Barbican services. Now I'm going to take you all through a one-on-one on the services. So what is Barbican API? Basically, the Barbican API is the main point of contact for users and for the instances to interact with the different services in Barbican. In the Barbican API, the users can, using this API, the users can create secrets. They can create secret containers and certificates. The instances can use this API to retrieve these secrets or the certificates to sign the certificates. Secondly, we have the Barbican worker, which handles the communication with the external CAs, and it is also used for the asynchronous part of the certificates. Thirdly, we have the Barbican retry, which is a legacy service for TLS certificate generation, but this is currently going to be deprecated soon in the next release. And it does not affect any asymmetric or symmetric key generations. And the other service that we have is the Barbican Keystone Listener. This service is basically a cleanup for the unused users from Barbican database. This is a simple example of the Barbican architecture. We have multiple instances of the APIs that can be run, and the users can access the API as well as the instances. The secrets and the other certificates are stored in the database, whereas the asynchronous requests for the keys go through the queue, and the workers can access this from the queue. And as far as the certificate authorities is concerned, this will be removed in the next release, most likely. That's all.
Okay. So one of the things that an operator needs to decide when they deploy Barbican is how the secrets are going to be stored. You can either have secrets that need to be in super secure storage, and so they may need to be stored and backed in with an HSM, some sort of hardware security module or something like that. Or you might have secrets that aren't quite that important, and maybe you can put them, encrypt them with an encryption key that's stored in a file or something like that. Fortunately, Barbican has a plugin architecture that allows you to configure the type of plugins that are going to be available to your projects. And as of Newton, you can actually configure multiple plugins, which could be configured by project. So you might, for example, have a development group that wants to keep its secrets inside a file-based development plugin, or you might have some production data and some key bank data, whatever that needs to be stored within a common criteria certified, FIPS certified HSM or something like that. You can do both of those. So some of the secret store plugins that are available, first of all, out of the box, there's a development plugin. It's not for production, so please don't use it for production. But the idea there is that all you have is you have secrets that are encrypted by a symmetric key that's stored in plain text in the barbican.com file. And then those secrets are encrypted and they're stored in the Barbican database. There's a PKCS11 plugin, which is actually in production at IBM. With the Luna SA, and this is something that talks PKCS11 to a backend HSM device. Basically, all of the secrets are encrypted by a project-specific key encryption key, which in turn is encrypted by a master encryption key, which is stored in the HSM. So all of the cryptographic operations actually take place within the HSM. There's a couple of others. There's a KMIP plugin, so if you have a KMIP device, for instance, you can talk KMIP to that device and store the secrets that way. And finally, there's the dog tag plugin, where secrets are stored within a dog tag KRA. The KRA itself is something that it can be backed either by a sort of a soft HSM kind of thing, a software-based HSM, NSS database, or it can be backed by a Luna SA or a Thales HSM. The important thing here is that all of this, when you do it with an HSM, dog tag KRA, as well as everything else there is FIPS and common criteria certified and so on, which is good for compliance reasons. And in fact, tomorrow in the workshop on securing secrets of the Barbican, we're going to be configuring Barbican with dog tag instances, and actually we'll be talking either to NSS database or to an actual HSM, and the HSM will be up there. You can see all the blinking lights and all that good stuff. So definitely come take a look. Okay.
Thank you. So now you know what Barbican is, and I'm going to show you what it can do. The first use case I'm going to present is encrypted Cinder volumes. So Cinder can create LUKS encrypted volumes, but on the other side you need to attach those to a Nova instance somehow. The way this works is Cinder stores them in a Barbican secret container, and Nova will open that encrypted volume on the compute node your instance resides on and decrypt it using that key retrieved from the Barbican secret container. And if you'd like to try this for yourself, you had an opportunity this morning. There was a workshop on encrypted Cinder volumes using Barbican actually. In case you missed it, we created heat templates for this along with some configuration instructions. So if you'd like to try it, the slides along with those heat templates are available online, and we'll give you a link later. And we tested this on Master and Mitaka. And yeah, the next use case is a bit more mundane, but that's actually what drove all the Barbican packaging we talked about. Magnum basically requires Barbican because its default setting is to use Barbican. And the thing it uses Barbican for is it creates CA certificates, which it stores in Barbican. And these CA certificates are being used by Magnum to sign SSL keys for the individual instances Magnum creates to make up a Kubernetes or Swarm cluster. And these instances retrieve the CA certificate from the Magnum API, and then they submit their own public keys to the Magnum API for signing. And all the CA keys reside in a Barbican secret container again. It's trivial to set up. Basically, you leave Magnum at its default settings and just make sure you have Barbican running. And if that's the case, it will just work, and that's why we didn't provide a heat template for that, because that would only show you how to use Magnum. The last use case is a bit more involved again. Neutron Load Balancer as a service supports SSL termination now, which is to say you talk to the load balancer created by Neutron through an SSL connection, and Neutron will talk to the instances on the other side through an unencrypted channel. The certificates used by that load balancer are also stored in a Barbican secret container. And now Neutron Load Balancer as a Service provides several plugins. Some of them create instances, such as the AHA proxy one, or some of them talk to appliances, such as an F5 load balancer or something like that. And sometimes there are deferred operations, which is to say there's a failover and Neutron needs to spawn a new instance, and that's where the secret container comes in, because then the Neutron Load Balancer as a service can retrieve that certificate from Barbican and spawn the new instance with the correct certificate. Again, we provided heat templates for this, tested on master and Mitaka, and I'm not going to keep you waiting for these any longer. Here's the link. Thank you. If you've got any questions, we'll be over on the other side of that glass partition, so feel free to join us. Thanks.